Okay, so we are going to be looking at exponential function and the natural log, so the derivative of both of these. So in order to do this, we're going to start with this investigation. So you are going to use your calculator to go ahead and fill in your table. So what you're going to be looking at is putting 2 to the x into your calculator and then putting a 1 in there. And then instead doing 2.1 to the first and then 2.2 to the first, etc. What you are going to then have to do also is you're going to have to take the derivative of the function. So a quick thing here. Okay, so using our calculator will evaluate this for us, so we don't have to take the derivative of each of these functions. So when we're in this column here, I need the derivative. So our calculator can do that for us. So into your calculator, please type in y equals 2 to the x. And then once you've typed that into your calculator, then you just go to second trace. And you're going to notice number 6 here is the derivative of y with respect to x. So number 6, we have to tell it the input value that we're going to be using. So we're going to be using 1 and hit enter. And it gives you both, down here, this is the output for our original function. And then up here, this is the output for the derivative at that value. So that's how you can use your calculator to very quickly fill in any of those values along the way in that table. Okay, so go ahead and use your calculator, put the new function in each time, and then you can find it. So what you guys just found out is this table, but the bigger part, I was expecting to hear like some moans and groans from you, because folks, your calculator will tell you the slope at any point in time of your function without you having to find the derivative. That's what we just did in that second column. Well, technically it's the third column. That's what we just did.
I feel like this is an average math class.
Okay. So what I want you to do is I want you to go through and note these questions. So I'm going to leave this up here so that you can see it, but I want you to go ahead and answer those questions based on the information that's given here. So if you look at the left-hand column, the base value here, 2.1, 2.2, 2.3, 2.7, kept getting closer and closer to E. Kept getting closer and closer to E. And then as I went past it, I just kept going by 1 more tenth. So when I look at the output of those values, so these values, f of 1, of course, is the same as whatever the base is, okay, because I'm substituting 1 in for x. But when I'm looking at the derivative, as I'm getting closer and closer to e to the x, what's happening to my f prime of 1? Keeps getting bigger. And what happens specifically at e to the x? They are the same. Their outputs are the same, no matter whether I'm looking at my original function, that's f of 1. So if I put e to the first, that's 2.718. And if I did f prime of 1, if I took the derivative of my function and substituted in 1, I got the same exact output. So therefore, f of x equaling e to the x, therefore f prime of 1 is exactly the same thing as f of 1 when our function was e to the x. So you are going to now calculate, right here it says, this first column right here says f of x, and then the second column is the derivative. So calculate those for each of your values in your calculator. Same output. It is exactly the same, so my function, e to the x, has the exact same output as, what does f prime of 1 represent? The derivative, when x equals 1, which means it's the slope. So the slope is same as the output value for each of these. They are consistently the same. Which means if f of x equals e to the x, then f prime of x equals e to the x and its derivative are exactly the same. The function e to the x and the derivative of e to the x is e to the x. So the output and the slope at that input are exactly the same. So the first thing is we just worked through why and how this works. Okay, so again, if I give you a function and we have to take the derivative of it, if e to the x is in there and I have to take the derivative of e to the x is just e to the x. This is another one we will not go through the proof as to why this is what it is. We won't work through this. But what I am going to tell you is if you have this special one, you have to memorize this one. If my function is the natural log of x, the natural log of x, the derivative of that is 1 over x. The derivative of the natural log of x is 1 over x, and that's one thing that you may just have to memorize. So we're going to work through these 4 problems. Please keep in mind that I might struggle fitting them in this space. Okay, so we're going to start with the first one. F of x equals 5 e to the x plus 2 times the natural log of x. So therefore, if we're going to do our derivative, f prime of x, we do each part different for sums. We do each part individually, excuse me, for sums, just like we did before. So 5 times e to the x, well, what's the derivative of e to the x? E to the x, therefore this is 5 times e to the x. Plus, now I have to do the derivative of this. 2 times the natural log of x. Well, what's the derivative of the natural log of x? 1 over x times 2. And that's it. So this had our 2 different scenarios in place. So I wanted to make sure I did one specifically with you guys that had that whole piece involved. So now what I'm going to have you do is I'm going to have you try B. B isn't super challenging. C, what are you guys going to have to do here? What's involved here? Product rule. You're going to have to do the product rule for this one. What's involved in D? Quotient rule. You're going to have to do the quotient rule with that one. So it's going to take a little bit more time. So I'm going to give you guys about 5 to 8 minutes to work through each of those individually, please. For the second one here, this one ends up using the chain rule because you have to chain on the derivative of the exponent. So if the exponent had like a 2x plus 1 or something along those lines, you have to take the derivative then of that. So therefore, this is g prime of x equals e to the 2x, and then chain on the derivative of the exponent, which is 2. So therefore, you'd write that as 2 times e to the 2x. And that's also where this statement comes in here. You'll see from the chain rule, if there is a power on your exponent, that power, we just chain on the derivative of that, so therefore it just comes down in front, attached by multiplication. Okay. For C, I'm going to do the derivative of each of these, so I'll do the v of x and u of x, or whatever it is that you want to use, just to make sure that you guys are as comfortable as possible with that for C. So therefore, u prime of x is just e to the x, and v prime of x is just 1 over x. So then we do h prime of x, u of x times v prime of x, plus v of x times u prime of x. And then nothing really happens here. My recommendation, this is typically something that we look for the chain rule and quotient rule. Do you see how they both have e to the x's in it? Factor out that e to the x. Again, not for anything we have to do here, but for other pieces we will. And that would be the way that we can then simplify stuff down the road. If instead you would rather write this as e to the x over x plus e to the x natural log of x, that would be perfectly fine as well. Okay, that's this simplified just slightly. Okay, so now go ahead and finish up D if you haven't yet. Again, define your u of x and v of x and do u prime and v prime, and then use your Quotient rule. Pull out that packet if you need to so that you can see the quotient rule in action. Okay, so for the quotient rule, it is the derivative of the numerator times the denominator. So j prime of x. So that's the derivative of the numerator times the denominator. Minus the derivative of the denominator times the numerator all over the denominator squared. Which gives us, yep, factor out that e to the x, natural log of x minus 1 over x, all over the natural log of x, whole quantity squared. Please make sure you put the squared on the outside because it's squaring the natural log of x. It's not squaring x. Nothing simplifies. You would leave it as it sits. Leave that one as it sits. Especially when we start looking at 1 over x's, we start to have some fractions and fractions, and we are not going to make you get rid of them. I mean, we could, but not at this point. Questions? I have 3 more problems for you guys to do that are all just natural log they're just all natural log questions. So just to give you guys a little bit more practice on those. I know you don't have them in your packet, but go ahead. You can fit them on your sheet somewhere if you want. Otherwise, do them on something separate. But these are the next 3 problems I want you guys to individually do. It just is another version of what you're going to see. Okay, so let's work on the first one. We can individually take the derivative of sums, so therefore dy dx equals, what's the derivative of x?
1.
1. What is the derivative of e times x? E. Because the power on x is 1, so we end up just getting the coefficients. And the natural log of pi is just a number, a constant. And what's the derivative of a constant?
0.
So it's 1 plus e is your answer for that one.
I'm just going to deep breath and work hard.
This one, how are you guys going to work with this one?
Change it to
Product rule. This is a product rule. And this one is not a product rule. What's this one?
That's a natural log thing.
chain.
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 We have to chain this one. So take a few moments to do those too. Okay, so I just listed out each of the functions. By no means do you have to do u of x and v of x. It just gives you that visual to see, especially when sometimes they're a little bit more on the challenging side. So therefore, dy dx is the one function times the derivative of the other plus the other function times the derivative of the other. And then we can simplify this. So x to the 1/2 is the square root, so it's the square root of x over x. Plus, okay, this guy goes to the bottom because it's a negative exponent. 2's on the bottom, natural log is on top, so that's a natural log of x over 2 times the square root of x. And at this point, based on what we're working with, probably going to leave it as it sits unless it asks you to write it as a single fraction, especially because this here can simplify further. So this here is the same thing as x to the 1/2 over x to the first. When bases are the same, what do I do to exponents? Subtract, which means and then multiply by 2 in the top and bottom, which gives you 2 plus the natural log of x over 2 times the square root of x. This part here you should be able to simplify for sure, because again, those bases are the same. So that's to the 1/2 power over x, so we subtract those exponents. Okay, so that one's a little uglier. The next one is not ugly, it's just we miss the chain rule all the time. So I wanted to make sure that we did a practice problem with the chain rule in there. So for that one, when I do the chain rule, so we're going to do f prime of x. So the natural log, the derivative of the natural log of this is just 1 over that, right? But now I have to chain on, which means we multiply the derivative of the inside. So what's the derivative of the inside? 4x. Therefore, my final answer is 4x over 2x squared minus 5. So just don't forget to chain that on. So we added 2 new functions. That's all we did. We looked at the derivative of e to the x, and we looked at the derivative of the natural log of x. Those are the 2 that we just added. Everything else was just practicing other things we know already. Okay, maybe looking differently.